So here in this problem, we are given the vertices of a triangle as points having the following position vectors. We need to determine the vectors corresponding to its sides as well as calculate the length. Okay, let us begin. So we will consider a triangle with vertices A, B and C. Now we will consider some point O outside the circle such that O represents the origin of the coordinate system. With respect to this origin O, we can define the position vector of the vertex A, B and C. So let's define them. So position vector, we're going to suppose that position vector of A is going to be defined by OA vector. So let's say this is given by A1 I cap plus A2 j cap plus A3 k cap. Then position vector of the vertex B, which is going to be defined by OB vector. So let's say this is given by B1 I cap plus B2 j cap plus B3 k cap. And then finally position vector of the point C, or the position vector of the vertex C, it will be OC vector equals to C1 I cap plus C2 j cap plus C3 k cap. Fine. Now let's define AB vector. So here we need to determine the vectors corresponding to its side. So we'll define AB vector, BC vector and CA vector. Now to define AB vector, what we'll do, we'll take the position vector of point B and from here subtract the position vector of point A. That's the definition. So that means we have OB minus OA. This will be B1 minus A1 multiplied to I cap added to B2 minus A2 times j cap added to B3 minus A3 times k cap. So this is the vector corresponding to the side AB of the triangle. Next, we will find out the side BC. So side BC is going to be OC vector minus OB vector. So that's going to be equals to C1 minus B1 times I cap added to C2 minus B2 times j cap plus C3 minus B3 times k cap. And then finally we are going to express the side CA vector with the vector CA as OC or OA vector minus OC vector. So that is going to be equals to A1 minus C1 times I cap added to A2 minus C2 times j cap added to A3 minus C3 times k cap. So we have successfully expressed the sides of the triangle ABC in the form of vectors AB vector, BC vector and CA vector. Our next task will be to find out the length. The length means we will be finding out the magnitude of each of the three vectors. Now magnitude of vector AB, that's going to be equals to, all we have to do is take the square root. Underneath the square root we have to take the sum of squares. So we'll start with the coefficient of I cap, so that's B1 minus A1. We're going to square this value, add it to B2 minus A2 whole square. So this is the square of the coefficient of j cap, and finally add it to the square of the coefficient of k cap. So we're B3 minus A3, square this value. Fine. Next we're going to find out the magnitude of side BC of the same triangle. We'll take the square root. Underneath the square root we have C1 minus B1, square this value, added to C2 minus B2, square this value, and then we have added to it C3 minus B3, square this value. And then finally we have a magnitude of vector CA, so that's going to be equals to, we'll take the square root, so square root of A1 minus C1 whole square added to A2 minus C2 squared added to A3 minus C3 squared. So we have successfully expressed the sides ABC of the triangle in terms of vector AB vector, BC vector, CN vector, and we have also defined its length as well.